Hello, so you're welcome once again to our math classroom. Don't forget to subscribe and click on the bell to receive notifications anytime we upload a new video. In our last lecture on Laplace transform, I did mention that the Laplace transform takes a function of time and transforms it to a function of a complex variable x. So we have a function of time f of t, and it transforms to a function of a complex variable f of what? X. So we looked at the definition. We said if I have the Laplace of a function f of t, then it is equal to the proper integral 0 to infinity e exponent st, the function f of t dt. And we made mention of some properties of this Laplace transform, and we started looking at examples on the Laplace transform. All these examples we are looking at is to build the Laplace table, which is very important and very necessary in solving your differential equation. So we'll still continue with our examples. So let's look at this example. So example, let's say I have the function f of t to be equal to t. F of t to be equal to t is what we are looking at. So we are saying, how do we go about it? So let's write the Laplace. So we have L of what? T is what we are trying to solve here. So it's going to be what? The integral e exponent s of t dot t d what? dt. This is what? Our function f of what? T. If you realize, we have what? Two functions. So you realize that we have an exponential function and a linear function. So it will interest you to know that with this, we can use integration by parts. Like I said in our previous lesson, that's for Laplace transform. It's very important to know your integration by parts. So if you solve, then we are getting t e raised to the power s of t divided by minus x from 0 to infinity minus the integral e exponent minus st all over minus x d what? dt. Okay, so this is what you have if you try doing the proper integral. So from here, what do I have? From here I have t e minus s of t over minus s minus e, so minus e exponent s of t over s squared 0 to infinity. Okay, so we want to solve. So in our initial, we made mention of the infinity over here. If our x is less than 0, then we know what happens. And if it's greater than the t here, if we pick the t to be less than 0 and greater than 0, then we know what happens here. So for the infinity side, we know everything is going to go to 0. So we are going to arrive at something like this: minus into bracket 0 for this part. So we just be left with this part to solve. So we have this part. So we're going to have 0 minus e exponent 0 over what? S squared, which is going to give us what? 1 over what? S squared, on the condition that our s is greater than what? 0. Very good. That means that if I take the Laplace transform of a function t, it's equal to what? 1 over what? S squared. So don't forget, so far we've said the Laplace of 1 is 1 over s. Then the Laplace of k, which we did, was what? K over what? S. Then we also looked at the Laplace of e exponent at, which is equal to 1 over x minus what? A. Then we just looked at this example as well. Okay, very good. So let's take another example. We did look at the Laplace of the cos of what? At. So we are gradually building the Laplace table. Now let's look at this other example. If I have f of t to be equal to t exponent n, where n could be from 0 to 1 to 2 to 3 to 4. We already know that the Laplace of t is equal to 1 over what? Laplace of t was 1 over what? X squared. That was the Laplace of t. If we take the Laplace of t squared, could you guess what we are going to get? So by a similar method, if you go through the method we went through for t, then we are going to get 2. Your final result is going to be 2 over s cubed. 2 over s cubed. Then the Laplace of t cubed will be what? What do you think t cubed is going to be? Okay, so let's look at it. So this is now t cubed. The Laplace transform of t cubed, we are saying is going to be 3. That is, let me write it this way. It's going to be the factorial 3 factorial over x raised to the power 4, which is 3 times 2 over x raised to the power 4. That is going to be 6 over x raised to the power 4. So this implies that for any positive integer where n is equal to 0, if I have a Laplace transform of t exponent n, then the general formula is what? N factorial over x raised to the power n plus what? 1. Okay, so that if I have the Laplace transform of t raised to the power 4, then what do I get? I get what? 4 factorial over s raised to the power 4 plus 1, which is going to be 3, 4. This is going to give us 4 times 3 times 2 times 1 over what? X raised to the power what? 5. For all s greater than what? 0. For all s greater than what? 0. Let's look at this other example too. So the basic foundation here is integration. So another example, f of t, it's equal to sin a t. We know that sin a t, it's from our previous lessons. Sin a t is equal to 1 over 2 e exponent a t minus e minus what, a t. Okay, so this is sin what, a t. So that if I want to find the Laplace transform of sin a t, then I have integral 0 to infinity 1 over 2 e minus s of t, then I have e a t minus e exponent minus what, a t, the what, the t. Okay, so this is what we have. So this is basically, let's write it out nicely. I have 1 over 2 Laplace 0 to infinity. So I have e minus x of t e a t minus 1 over 2 Laplace, the improper integral e minus s of t e minus a of t dt. So I have dt here. Let's not forget our dt. So with this is what, 1 over 2. This is what, the Laplace transform of what, e raised to the power at minus 1 over 2, the Laplace transform of what, e raised to the power minus what, 80. Okay, so we already know the Laplace transform of e raised to the power what, 80. We know what that is already, which is 1 over 2. So the Laplace transform of this is what's 1 over x minus a, which we did in our first lecture on the Laplace transform, minus 1 over 2. Then that of this is going to be 1 over s plus what's a. Okay, so let's solve. If we solve, we have what, 1 over 2, 1 over s minus a minus 1 over s plus a, which is going to be equal to a over s squared minus what, a squared, for s greater than what, a. So we can then conclude that the Laplace transform of sin at is going to be equal to a over s squared minus what, a squared. If you go through the same process for the Laplace transform of cos at, then you are going to get s over s squared minus a squared. This, I ask you to verify and give your comments in the comment section. So now let's take examples of functions, Laplace functions. So let's say you are asked to determine Determine the Laplace transform of 1 plus 2t minus 1 over 3 t raised to the power 4. Okay, so how do I go about it? So let's look at it. Let's take it one after the other. This is more like you have, what do I have? I have the Laplace transform of 1 plus 2 Laplace transform of t minus 1 over 3 Laplace transform of t raised to the power 4. What is the Laplace transform of 1? The Laplace transform of 1 we know is what? 1 over what? S plus 2. And the Laplace transform of t we know is what? That's 1 over what? S squared minus 1 over 3. And the Laplace transform of t exponent 4 is what? 4 factorial over what? S exponent 4 plus what? 1. So this is what we have. So what do we have here? We have 1 over s plus 2 over what? S squared minus 1 over 3. 4 factorial is of 4 times 3 times 2 times what? Times 1 all over s raised to the power what? 5. If we evaluate, we are getting 1 over s plus 2 over s squared minus what? 8 over s raised to the power what? 5. This is our final words results. Do we want to take another example? Let's take another example. Let's take this example. We want to evaluate the Laplace transform of 5e exponent 2t minus 3e minus what? T. Okay, so let's look at it. So we are looking at the 5, the Laplace transform of e exponent 2t minus 3l e exponent what? Minus what? T. Okay, so we know that from here you realize that we said the Laplace transform of e exponential at is equal to 1 over x minus what? A. So that is what you have here. So here our a is what? 2. So here I have 5 1 over x minus what? 2 minus what? 3. Then we have e exponent what? Minus what? T. This time it is what? Minus. Okay, so we are going to have 1 over minus s. So our a here is what? 1. So this part, you realize that the coefficient of t here is what? 1. Means that the a here is what? 1. So I have minus a, which is minus what? 1. So then what do I have? So I have 5 over s minus 2 minus 3 over what? S plus 1. X plus 1. So you could solve you could do the evaluation. If we do the evaluation, what do we have? What do we have? I have 5x plus 1 minus 3x minus 2 all over what? S minus 2 s plus what? 1. Okay. And this will give us what? 2s plus 11 all over s squared minus s minus what? 2. So there are so many examples you could look at. You just have to be patient and go through vigorously. Don't forget, integration is still the basics, so you will need to do a lot of revision on that. Thank you so much for joining our math classroom. Until our next lecture, stay safe, protect yourself as well, and don't forget to subscribe. Bye.